Come on, y'all.
It's National Goof Off.
It is National Goof Off Day. I've already done that for 10 minutes of class.
Good.
10 minutes of class gone. We haven't done anything yet.
Good.
Let's goof off some more.
Yay!
All right.
So if you put on that thing where you have to dance.
Yay, the pen doesn't work. The pen doesn't work.
Yay, the pen doesn't work. The pen doesn't work. Am I on pen? No, I'm on the mouse. Oh, I'm on the mouse.
No, but what?
Pen.
The universe does not work.
Pen don't know where please.
There we go.
No.
Yeah, you are wrong. All right. So we have the choice,
Oh, what?
right? Cartoons or Marvel?
Cartoons.
How many vote for cartoons?
Cartoons.
2.
Yeah.
How many vote for Marvel? Whoops, this would be cartoons.
Oh.
Cartoons?
Cartoons.
1, 2, 3, 4. And how many vote for Marvel? 1, 2. Oh, looks like cartoons wins. Okay.
Yay.
All right. It is Winnie the
At
Pooh.
least Scooby-Doo's on there.
Scooby-Doo's on there. Who else? Tweety Bird.
Bunny.
Not Roger Rabbit. Bugs Bunny. Bugs Bunny. Okay.
Who's Roger Rabbit?
Peter Rabbit.
Roger Rabbit is a movie from the 80s, I think, a cartoon movie.
I want rabbits.
It's actually live action with animated characters in it. It's not very, it's kind of a weird movie.
It's
Jessica Rabbit, you know Jessica Rabbit?
No.
awesome movie.
You like that one, Terry? Who Framed Roger Rabbit? That's the name of it. Anyway, all right. What do you like here on this list, Olivia?
Scooby-Doo.
Oh, Carlos says Scooby-Doo. We'll give you a couple Scooby-Doos. 1, 2
Bugs
Scooby-Doos.
Bunny.
Bugs Bunny. Okay, we'll take them in
I
there.
like Winnie the Pooh.
Winnie the Pooh. We'll give a 3 Bugs
It's not
Bunnies.
thick enough.
Okay, Winnie the Pooh.
No, ew.
One Winnie the
5 more Scooby-Doo's.
5 more Scooby-Doos. Wow, it's a good thing I can get them generated so quickly. 4, 5,
3 more Bugs Bunny.
3 more Bugs Bunnies. All right, we'll stop with that. 1, 2,
I want to get one Winnie the Pooh.
3.
We don't have
Oh.
Tweety Bird or Mickey Mouse.
That's okay. You don't have to have all of them represented here. We'll do another.
Scooby-Doo.
All right.
Scooby-Doo.
Now, I'm going to represent these different characters with a letter.
So
Oh, no, I want to do it now.
variable.
Of course.
This is so actually yet entertaining.
I
S.
don't watch it.
S for, how many Scooby-Doos are right here?
2.
2.
5.
Okay, so I'm gonna say there's 2 Scooby-Doos, like that. Okay, how many Bugs Bunnies are here? 3. 3 Bugs Bunnies.
9.
2 Winnie the
3
Poohs.
blue.
5 Scooby-Doos. 5 more Scooby-Doos. Oh,
Scooby-Doo.
and 3 more Bugs Bunnies. All right, now this is a topic from last year, so this should look somewhat familiar to you. What am I going to do to simplify this picture?
Watch
Carlos.
Scooby-Doo. Watch Scooby-Doo.
Yeah, no. Okay, so that's 2 smart aleck answers so far. And 1 more. Now I'll give you 2 more chances and then I'll rate you up. Okay? I'm teaching a class of math here, Carlos, and I don't need you trying to derail my class. I know you're good at that and you do it in other classes, but you're not doing it in here. Let's get back to what we're doing here. What am I going to do to simplify? Are you happy that I did that, Tori? You don't have to say yes. Okay. Anyway, Carlos, what am I going to do here to simplify this situation? Why don't you participate properly? Because I know you're smart enough to do it. So, what can I do to simplify this situation? It is an expression. If you put plus signs in between all these things, it's an expression, a variable expression, right? This is what I have. What can I do to simplify this? Tori has an idea. What is your idea, Tori? Add the similar things together. How many Scooby-Doos are there here?
7.
There are 7. Okay, I don't have a 7 down here, so I can do 7 S's. What else can I put together?
Bugs Bunny.
6 Bugs Bunnies.
Bugs Bunny.
6 Bugs Bunnies. And 2 Winnie's the Pooh.
Winnie's the Pooh.
Is it Winnie's the Pooh or Winnie the Pooh's? What do you think?
Winnie's the Pooh.
Winnie's the Pooh?
Winnie
Winnie the Pooh's. Right?
No S. It's just
Well, if there's two of them, no, there's not two Winnie the Pooh. Well, it could be like two deer, right? The plural of,
Winnie
yeah.
the Pooh.
anyway. Okay, we won't have a LA class here, but pluralizing things like,
I
you're
like LA.
like a sister-in-law, right? Like you don't have sister-in-laws, you have sisters-in-law if you have more than one.
We need to call them Winnie's the Pooh.
Winnie's the Pooh. Winnie's the Poohs?
Yeah, Winnie's the Pooh.
Okay, so notice that this expression is way simpler than this one. And what did we do to simplify this expression?
Added them up.
What did we add together?
Numbers.
The similar variables. We added the similar variables. Okay, there's actually a math term for that is like terms.
Can we do the marble one?
We can do one of the marble ones. All right, let's go to marble. Okay, what do you like?
Spider-Man.
Thor. Oh, I like Thor too.
I'd say none of these. but-
Thor, you can say none of them. Thor, we'll do two. How many Thors? We'll do
I
three.
got the Captain America.
Three Thors, one Captain America, What else?
Spider-Man.
8 Spider-Mans. That's too many for me to drag around. I'm gonna do,
7. You did
Three.
it last time.
I did all together, but I gotta have them separated. Who? What
Two
else?
more Americans. What about Black Panther?
Two more Captain Americas.
Yes.
6 holes.
Some Black Panthers.
You need like 10 Black Panthers. No.
Yeah.
You wanted more Spider-Mans, you said,
And we need some Hulk. We need some Hulk in there.
and one Hulk.
No.
Hulk smash. Okay. All right. So, what do we have here now? We got 3T plus
Did that hurt?
1A, no, plus 3 S's, plus 2 A's, plus 2 S's, plus 1 H, plus 3 B's. That was a lot. This is a really long expression here, really long, but we can get this simplified by doing what?
Adding numbers.
Adding which numbers? Can I add Hulks together with Thors to get Hulk Thors?
Yes.
No.
That's how it works in
Okay, I could mutate them if I were to multiply them together, but we're not multiplying these things together, we're adding them. So no Hulk Thors, Captain Spider-Americas.
You can do Captain Thor.
Okay. You like Captain Spider-America?
Yes. That's
Okay. So if I simplify this expression, what am I left with?
3T.
3T, 3 T's, plus 3 A's, right? Because there's a 1A plus 2 A's,
Wait,
Right,
don't
so
we need a
you-
duplicate of everything so we can add them?
plus 5 Spideys, plus 1 H. Now, if I don't put a 1 in front of this H,
That means multiply.
pardon me?
About the Black Panther.
Oh, I forgot the Black Panthers. Plus 3B right there.
Oh, hey,
No, I'm just kidding.
if you multiply the spider and the panther, it'd be a Panther Man.
Panther Man.
Panther Man.
Okay, that is my simplified expression. Now, this H here doesn't have a 1 in front of it.
That means this is 1.
That means it's just 1, exactly right. Okay, if there's no number in front, then it's just 1. Okay, so what we just did here with cartoons and marbles is a review of your lesson from last year on combining like terms. Simplifying an algebraic expression by combining like terms.
Can we see which one has more votes?
What the book did on all these. 2x plus 3 plus x plus you fixed it, right? You guys knew what the answer was already because you're smart. It was 3x plus 1 and your drawing looks like that. What happened to what do we have call this when you have a plus 1 and a minus 1 together? What is that called?
0.
A zero. A zero pair. I knew I was going to be able to put my foot down. A zero pair, right? When you use algebra tiles and you have a positive and a negative, it equals 0. It's called a zero pair.
I
Okay.
swear if you fall, I was gonna be so.
You'd be laughing?
A little bit, but I would have been
It's
nervous.
okay. You should be nervous.
I would have just laughed.
Okay.
I didn't get anything on that page.
No!
Hey,
No,
there.
only her, because she says she laughed when you fell.
Oh, I can't do that now. COVID times. Sorry.
What?
Can't have you pass papers back. I have to pass them out to everyone.
What if you?
That would be
I
so
don't.
fun.
What if you?
I already had it. I can't have it again.
Power School is running extremely slow. If you're unable to do attendance, just send me a quick email letting me know if you
Already
have
done
any
it.
aspects. Thank you.
Done. You are so welcome, Jeff. So welcome.
You should have only gave this to Olivia. She's the one that said she laughed at you.
Okay. So we're going to talk a little bit of vocabulary here first. Should be review. Okay. When you have algebraic things that are separated by additions or subtractions, that is not the worksheet. These are notes. These are class notes.
Oh, good.
And it's punched on the wrong side, so we're actually on the second side. I punched the holes on the wrong side.
So is that?
I lost my proficiency in using the copier because I've only used it for 3 worksheets so far this year, and
Yeah, you should know how to use copier.
okay, so this expression, negative 4x's plus 12 plus x, has 3 terms. Terms are separated by additions and subtractions. Okay? Like terms, which we already talked about, right? This is Black Panthers plus Black Panthers. I can put them together, or Winnie the Poohs and Winnie the Poohs. Like terms have the same variables, and they also have to have the same exponents on variables. So if there's an exponent on a variable, it has to be the same exponent in both terms for them to be alike and let you add them together, okay? So 3x to the second and negative 7x to the second, those are like terms, x to the second.
You know, you're not. What if you
Okay.
say it's okay?
Okay, now you can also have terms that have no variables, just a number, and that is called a constant. Constant, not a variable, right? Variable means it varies, it can change. Constant is always the same. That's a number that doesn't change. I'm on page 388 in your book, which is where you should be following along. But I said it on this page here, 387. Come on, it's the book. I'm not on that. That's notes that are not in the book. So again, normally this is like the second day of class that we have this discussion. Book pages will tell you what page we're on, okay? Notes pages will have a little notes yellow sticky on them in the presentation. You'll see one here in the next page. Okay. So off to the side here, it says stop and reflect. Circle the term below that is a like term with negative 4x to the third. Which term is a like term with negative 4x to the third? Yellow sticky in the left margin, go.
What?
Huh?
Page 388 in the left margin is this
What's a
little
margin?
sticky. Margin, that's the side of the page, right? The edges of the page. This sticky that says circle the term below that is a like term with negative 4x to the third. Circle the term that is a like term with negative 4x to the third. With x to the third, right? X to the third is the variable and exponent combination that you have to match. So that's the one. Okay, so it's okay. We'll continue. Oh, this is a notes page. See this little yellow sticky up here? That means it's not in your book, and you should have a handout for it. Right? And you do. So this is just reviewing what we just did in the book. When a plus or minus sign separate algebraic expressions into parts, each part is called a term, not like terms yet. Okay, a term. How many terms does this expression have?
3.
3. 2x squared is a term, separated by addition. 5x and negative 4. It's not minus 4, it's negative 4. It looks like minus 4, doesn't it? But subtraction is always
That's a negative.
adding the opposite.
That one is
Why
not.
does
That's a
that
negative
one look
4.
so close?
That one is.
Yeah, that's a
That one
negative
looks
4.
like
That's a
negative. The
subtraction
other one looks like
sign.
a
Okay, so one thing that we are going to do, because we want to be able to group these things together however we want, right? And what has to be true, what operation lets us group things together however we want? Not subtraction, only addition. And and multiplication. But now we're talking about addition. So if I want to group things together, they have to all be additions. I don't like subtraction at all. I'm going to get rid of it every time by doing what? Keep, change, change. So this really is the same as this.
You're mean to subtraction. You bully.
Yeah, subtraction is not flexible, right? Subtraction doesn't let you switch things around.
But that's bully.
So this expression is really this, which means the other term really is -4. Okay? How many terms are there in this? 3. And what are the terms, Carlos? Go ahead.
So since everyone's back or something, like, are we still waiting 2 minutes to dismissal?
Yes. More importantly now. Okay, there's 3 terms in this expression. What are those terms? Colin, what are those terms? Terms are separated by additions and subtractions, which actually they're separated only by additions. Chloe, what are the terms in this expression? Give me one of them. Terms are separated by additions.
X to the second.
X to the third, that's one of them, okay. X to the third is a term. What's the next one? Tori.
2x.
It is not 2x.
It's negative 2x.
It's negative 2x. They have to be additions. Negative 2x. And finally, Chloe, 3. Three terms, okay? X to the third, negative 2x. And if you want to, you can rewrite this. You see subtractions, you're like, we don't like subtractions.
Keep, change,
You change, right? Change the number after the subtraction to its opposite.
Why do you keep change? I thought it was same change.
Same change. Okay, same keep. You're right. Get it straight, Mr. Riley.
Yeah, get it straight.
Okay. All right, the number, they didn't go over this in the book, I don't think. The number in front of the variable in a term is called a what? Starts with a C.
A constant.
Constants are these down here. A term without a variable. That's a constant.
So from the Z.
C. It actually starts with the same first 2 letters as constant, which is why people get it confused.
Coefficient.
Coefficient is correct.
Come on.
Tori, on a roll. A coefficient is the number that a variable is multiplied by. The number right in front of the variable is a coefficient. Now you have a notes page in front of you, right? And I'm filling in blanks in the notes page. So what should you be doing? As I'm doing these notes, what should you be doing? You are.
Check. Right or wrong?
Hello, Mr. Early.
Back in the game, baby.
Oh man, it's so great. I got worksheets out there. I can ask questions.
No.
John Carlos paying attention.
John Carlos
No.
only has 2 inappropriate answers to questions. He has 2 more before he gets written up. So he's
Okay,
doing good after the
okay,
morning.
then no one.
Okay,
Wait,
He's doing good.
It's only 3. You should make it 1 more.
2 more. I didn't warn him until after the second one. He's doing good. All right, now, terms that have exactly the same variable with the same exponent. Don't call out, Miles. Like terms. Like terms have the same exponent and same variable.
These are big words.
They are big words.
Very
Oh
big
no,
words.
did I already circle these?
He's giving us answers.
Oh no, this is notes. Okay. So these are examples of terms that are not like terms. 2x and 6y, the letters are different. Those are not alike. You can't add them together. 3x and 6x to the second. The exponents don't match. You can't add them together. They are not alike. Okay, these are sets of like terms, which you can add together, which is what we did with Marvel and cartoons, right? These are not like terms. Okay, and again, constants are terms without a variable, and constants are like terms also, right? If it's just a number, you can just add them together. What do you think, Diego? You following along? Diego? You following along?
He's sleeping.
Sorry to bother you. Okay, a final notes page here before we go. On this page, these three blue numbers are called what? Don't call out. This red 12 is a what? And these two things here, -1x and 5x, are called what? Larry?
Like terms.
Like terms. The green box are like terms. The blue numbers here are Pixie. Coefficients, excellent. And the red 12 with no variable is a Kathy, constant. Okay, these three words, terms, actually, like terms, coefficients, and constant. You need to know those.
Really?
Okay?
Oh.
Oh, there's an IXL on this stuff. Maybe I should assign that. All right, page 388. So now the book's going to talk about these things. Identify the terms, the like terms, the coefficients, and the constants. Okay? So again, notice the book does this too. All the subtractions, they rewrite as plus a negative. You don't have to put them in parentheses if you don't want, but you can put them in little mittens, negative number mittens. Okay, they also put in the invisible one here, right? If there's a letter just by itself,
It means time.
it means there's one of them, right? So you can put a little invisible one in front of there.
Are we not gonna do that?
Not yet, but we'll get to it. Okay, so list out the terms here. 6n, -7n, -4, and n. Those are the terms. The like terms, there's 3 n's, so those are all alike. 6n, -7n, and n. Those are all like terms. The coefficients are numbers that variables are multiplied by. 6, -7, and 1. Right? This one coefficient, that's why I kind of have to remember that that's there. And the constant in this problem is -4. Okay, there are two got it problems here. Off you go.
You don't have it, you gotta do it.
Well, you could be doing it on your paper if you wanted to follow along properly in class, even though you're unprepared.
I honestly don't understand.
You don't know how to identify the terms in this first one
You're
here,
highly not wrong.
okay? What are the terms? And first off, what's the first thing you're gonna do? Because we don't like them, we're going to change them.
Addition.
Rewrite everything as addition. You can do it right on there if you wanna just do the, put the
That
plus
looks
on
like
it
a
and a little minus sign.
cheat.
That's perfectly fine, right? If you wanna do this, instead of rewriting it, this is okay.
You have to do so much more work.
Acceptable, like this, plus negative, like that, right? You can do it that way.
It's so entertaining. How did you say Captain Spider Americas?
Captain Spud Americas,
That was
you like
fun.
that?
Or Paper Man. Oh, what's your name?
Or Black Spider,
Can you do the whole snack? That's everything.
you liked it? The Hulk
Sure, I
smash.
did act. Not you, you.
Can there be
Excellent.
more, can there be more than one question?
Yes, there can. Yes, in letter A, there are, and there's, that
I don't
also
know
makes
what to
them.
The answer to this question would be math.
I'm like calling.
All right, so over here, how we doing?
Nor do
What are
I.
you doing? Are you combining things together there? We're not doing that yet.
I don't know what
All we're
I'm
supposed
doing.
to be doing here is identify.
That's probably not.
What page are you on? That's the old homework you're looking at. Why don't you call up the notes page in classroom for today?
I'll
It
give
says-
a try.
Notes for opt-out. Pretty sure I posted it.
In the street.
Not for him, no.
I think I posted it for everyone. Did I not post it for everyone?
No, for opt out. Is he's not.
Did I only
opt
post
out.
it for opt-outs?
Yeah, go look. Go look.
Join the.
Go look. Humor.
It's possible. That means that if I posted it for other people, it would automatically tell me who was unprepared for class.
I do not have
I didn't get anything.
Students, two students.
What? You didn't get it?
Yeah,
Who's that, Rory?
yeah.
The only person on me.
Notes pages for today?
already?
Don't have it.
I gave it to you. Did you look on in classwork?
Why do you have this open?
I'm reholding.
So she can, what? You still don't see it?
Giancarlo,
Reloading.
Colin, and Cameron.
Just assign it to everybody.
Just relax.
Go to your classwork tab.
Oh no, my pencil's done.
Never mind, I got it.
Okay, good. Good. Where was I? All right, so we have plenty of time to do these now. Okay, so the terms
I don't know what to do.
The terms are separated by addition. 9y, -4, -11y, and 7.
What do you want us to do?
Answer the question like the example. Look at the example and answer the got it question. Every time, that's what we do in math. Here's an example, then you do it like the example. What are the like terms in this expression? 9y and -11y are like terms, and so are -4 and 7. Because constants are also like terms. They have no variables, so you can add them together.
Why must math be so confusing?
Coefficients, 9 and -11. And the constants are -4 and 7. Okay, so this was rewritten down here like that. This one, you can also rewrite all the subtractions. And then your terms are 3x, 2, -10, and -3x.
Okay, wait, I need to write all this down.
Your like terms are 3x and -3x. And your other like terms are 2 and -10. And your constants, 2 and -10. And your coefficients, 3 and -3.
Oh,
Okay.
really?
I need to write
All right, so I will assign IXL on this stuff for practice.
Ben, can you take away the worksheet?
Okay, the worksheet, it doesn't have any of these on there. That's
The
why.
worksheet graded?
Everything's graded, Carlos.
I know ours when I
Like
did the
effort
worksheet
or-
because
Effort.
I need to write all that. down.
It'll be posted later today, the completed notes. If you can't keep up, the completed notes will always be posted.
When's the worksheet due?
Thursday, no, Wednesday. All right, now, back to what we did with the cartoons. Simplifying an expression by combining like terms. Okay? So simplifying the expression means identify the like terms and add their coefficients together. So if I have 4y's plus 1y, like 4 Yosemite Sams plus 1 Yosemite Sam,
What's a Yosemite?
gives me
Sam?
5 Yosemite Sams. You don't know who Yosemite Sam is?
It sounds like Colorado.
Oh, here we go, she says. Oh, here we go.
Yosemite Sam.
He tries to kill,
Nice.
yeah.
This guy.
Doesn't he try
Seen
to
him
kill
before?
Bugs Bunny?
He does try to, yeah, he does chase Bugs Bunny, I think, yeah, quite a bit. There he is over there trying to get him. Okay. Anyway, that's Yosemite Sam. Okay, so anyway, if there were 4 of them and 1 of them, you could combine them together to get 5. So the simplified expression, the answer for this one is 5y. Now this shows in the book why they did the distributive property before this lesson. I don't agree with this, but that they took the coefficients and said you can add the coefficients together and then multiply by y. I prefer to just think of this, the number here is how many of these y's you have. So you're just adding up the ones that are together, okay? Now, number 3, example 3, way harder than example 1. What makes number 3 way harder than example 1?
Bigger.
Well, it's bigger, but what makes it really harder?
It's bigger.
There's more.
There's subtractions in it, which means when I add these terms together, I'm going to have to add positive and negative numbers, which makes it way harder.
I thought you-
You did these problems last year. This is a 6th grade problem. This is a 7th grade problem because it has negatives in it. So again, the first thing you're going to do is change all the subtractions. That's this step, right? That's same, change, change. Same, change, change. Okay? Then you add up the like terms. You do not have, yes? Now, one way, there's kind of a trick that people use to identify the like terms in an expression like this. And that is, you can cover them with different shapes. Okay, we'll do that first. So let's take all the x terms and put squares around them. Does this get a square? No. Does this get a square? Yes. And this? No. So I have a 7x and a negative 7x. Okay. Then my next term is a constant. I'll put a circle around that one. And then, does this get a circle? Yes. Sorry, I drew a line underneath. That's kind of confusing looking. Whoa, that's a fat eraser. Okay, so circles around the constants and squares around the x terms. That lets me figure out what to add together. You do not have to write these steps. Optional steps to write in your work, okay? You should be able to add these together without rearranging them. Since it's all addition, I can group them however I want. So I can add the like terms together. 7x plus negative 7x is 0 x's. They're gone. Negative 2 plus 6 is 4, using your positive and negative number rules. So these are much harder, right? You'll be very glad. No, you will not be glad to know. You will be glad to know there's no negatives on the homework worksheet.
I'll be glad to know that I'm.
Okay. So the answer here is 0 x's plus 4. Well, 0 x's is nothing. So the answer to this one is just 4. That's the simplified. This is a pretty complicated expression. It's the same as 4. These are equivalent expressions, meaning if I put a number in for the variable, they'll come out to the same answer. Obviously, here they'll always come out to 4. Okay? Equivalent expressions. That means that if you put the variable, if a number in for the variable, the two answers will be exactly the same. Okay? All right, so here's some got it. Combine the like terms for these 3 problems and simplify the expression. Simplify the expression.
I don't know how to do
Okay, so
that.
we're going to change subtractions to addition first. Keep same change. Then we are going to identify the like terms. Which ones have the same variables. Then we're going to add the coefficients, the numbers in front of them. We're going to add them together. So, where are we at?
You move.
Right here. Okay, so first we're going to rewrite it so there's no subtractions. Change, make it a negative. Right? Change that to plus. The number after it has to change to its opposite. So it's not z anymore. Now it's negative, and you can put in an invisible 1 there if you want to. Okay, now you're going to add the like terms. Do you have like terms there? Things with the same letter?
Mm-hmm.
Yes. So you can add their numbers together. Add the coefficients together.
Z.
Doesn't matter. Your answer is going to have a z in it. It's going to be something z. What is that number now? How many z's do you have in this problem now? Nope.
21.
No, you have 4 and negative 1. So if you combine them together, how many do you have?
5.
4 and negative 1.
Oh, 3.
3. So your answer is
Crazy.
3z. That's it.
What?
3z. That's it for the first one. All right. You could rewrite this if you want. 4z plus negative, write the invisible 1z. 3z.
Hey, Mr. Riley.
Good.
Mr. Riley.
Good.
Not the first time.
What are you doing? What are you doing? Can you see these problems on the board? Yeah, then write one down and do it.
Mr. Riley.
Yes, ma'am. You don't have to write all the steps that they do up here. These are all optional. Okay, you can just write your answer. Right, all the steps they show in the book, which happens a lot, are optional.
Oh, good.
So write down a problem on your paper. You can do it right here on the notes page. You got plenty of room there. Write down one of the problems and try to do it. Do letter E. That's the hard one.
Me?
Yeah.
I can't do that.
All right, then do letter C.
Mr. Riley.
Good.
I have a big
Good.
burrito. It's in my bag.
Keep going.
Oh, okay.
Will you give us some time in class to do our homework?
If I get to it, I don't think we'll get to it though. We're trying. Well, it depends on how long do I give you for this, or should I just give the answers now?
Answers.
It's all a trade-off, right?
Answers.
How much do you practice where I can come help you? Right? It's all, that's how class works.
Class is just confusing.
All right, what's the answer to letter D? What's the answer to letter D? Kathy? Carlos? 6, that's correct. Yep, because you have -3n plus 3n, right? Now, if I was gonna identify the like terms here, okay, I got a 6, that's a constant term. Other constant terms I'm gonna circle, there aren't any. Then I'm gonna go, okay, there's a -3n and another n term, and if I add -3 plus 3, that equals 0.
Wait, so I got it right?
Yes, correct.
I just did 6 minus 3 plus 3.
Yeah, that's okay, but you can't really combine them all together, right? You can only combine the ends together. Okay, so on this problem, the last one, it won't work out quite that easily.
So we'll do it.
First step, boot the subtractions. Get them out of here.
Is this
Give them,
subtraction?
Hulk smash the subtractions, Olivia.
Where's the subtraction?
There's 2 of them,
I see addition. Oh,
right?
down there it's addition.
That's because I changed them, right? I Hulk smashed the subtractions. Now they're plus a negative. Now I'm going to identify the like terms. 2g gets a square. Does that get a square? No, it doesn't have a g. Does that get a square? No, it doesn't have a g.
Yes.
That gets a square.
Why?
Okay? -3. I'm going to go triangle on the constants. -3. Does that get a triangle?
Triangle.
Yes, because it's no variable means constants are also like terms. Now I can add together 2 plus -8, -6, and -3 plus 11 is 8. Okay? So here's your answer, -6g plus 8.
That's the answer to the problem.
So negative.
Yeah, that's the answer. Just like with the distributive property problems we talked about on Thursday, it kind of disturbs you that that's the answer, like it's not a number, there's a letter in there still. This is the simplified expression, right? This is way simpler than this one, right? We cut it in half. We really simplified the expression.
Can we do another cartoon? That was fun.
Okay, now you might also have 8 plus -6g or 8 minus 6g. These are other ways of all writing this same expression. As long as it's addition, it's commutative, so you can change the order. That's what this one is, changing the order, putting the -6g after the 8. And you can also always change plus a negative to subtraction, or vice versa. Okay, so any of these 3 would be acceptable answers. This one, though, is the one you'll see in your book. I mean, not in your book, in the worksheet and in the book. Actually, the book rewrote this one as a subtraction. The worksheet you have for homework is going to write it like this because this answer is stylish. Right, Stephanie? What makes it stylish? The variable terms come first and the constant term is last. And if there's more than one variable, they are in alphabetical order. That's the stylish answer, which you'll see on the worksheet. Okay. What? You confused, Carlos?
There's no something else. I want to ask you like.
I'm going to skip this one for now.
Yeah, I don't want to do
Real world problems. And
optional.
we can just, that's an optional step. We just talk about this real quick. Okay, this is a problem in the book.
We have to do the problem.
I ate
We'll skip this one too.
Yay!
And we'll skip this one.
Yay!
And we'll skip these.
Really? No, you said we'll skip up. Come on.
Okay, and we'll go back to Thursday real quick. This is on your notes page. All right, we had this notes page and these examples we did on Thursday, but you didn't have them in front of you to write on. Right? Maybe you were following along on your Chromebook if you were at home on Thursday.
Yeah, these are easier.
So I reprinted them for you. This is a review of what we did with the rainbow method, the distributive property on Thursday. Okay? And now that we know we can't combine like terms together, we'd be a lot less likely to try to add these two things together because we know now that we can't add them together. They are not like terms. You can't combine them. Okay? So let's take a look at these distributive property practice problems that we skipped on Thursday. So here we go. Let's go over these so we can move on to the next thing. So Rainbow, you can write this step like this. It is optional at some point for you to write this middle step. Many of you, if you're getting these all right, you can go right from here, right to the answer. 40 plus 28, 40 plus 70A. Okay? So this step in the middle that I wrote is, if you're not getting these right, you need to write this step, the individual multiplications of the rainbow. If you're getting them right, you can skip this step and just write your answer. Okay?
I thought it was just going to be 21A.
Yeah,
but 4 plus 7.
Yeah, but why can't I do 4 plus 7A here? They're not like terms. A constant and an A, I can't add them together. I can't add Bugs Bunny plus a Scooby-Doo and get a Bugsby-Doo, right? I
Scoo
can't.
bunny.
A Scoo Bunny. That doesn't work. Okay? So you can't combine them together. This one, plus a negative. So my intermediate optional step here would be 5 times 2x plus 5 times negative 3. So that's going to be 10x, 5 times 2 is 10, plus negative 15, or stylishly, I don't like plus negative in my final answer, I would write that as 10x minus 15. But you could also do by just not changing this subtraction. Since this number out here is positive, that would work also, okay? Either of these answers are okay. Okay, either is okay. Except not on the pizzazz worksheet because it's only going to want this final style.
How many problems are in the pizzazz?
A lot, but I'm not going to assign them all. There are 24 problems, but I'm not going to assign them all.
Sign about 2.
Okay, here, negative 7x times 3 plus negative 10 times 3. Negative 21x plus negative 30, also known as negative 21x minus 30. Change the, change this to plus a negative. Negative 2 times, negative 2 times 7 plus negative 2 times negative 3x. Positive and negative number rules you get in all these, right? So negative 14 plus 6x. If you did 6x minus 14, that's actually a more stylish answer.
No, I did 14 plus negative 6.
Oh, so yeah, you messed up the minuses somewhere. Maybe missing that this was a minus in the front. Number 5. Running out of time. Negative 4 times 5x plus negative 3. So that's negative 4 times 5x with your rainbow.
It doesn't look like a rainbow. That's negative.
And negative 4 times negative 3, which is plus 12. Negative 20x plus 12. And the last one is a challenger. X times negative 5x plus x times negative 3. Okay, so that's 5 times x, negative 5 times x, which Jasenia and I figured out the cool way to write that is negative 5x to the second, right? X times x means x to the second. So you will not see any problems like this.
That's a lot of X's.
What?
That's a lot of X's.
There's a lot of x's, which is also why we don't use x's for multiplication signs. Because otherwise you get x's all over the place and you don't know which ones are x's and which ones are multiplication signs.